Vedika Sarnamar. We are doing a project on embedded system. Small interactive memory trainer using microcontroller-based Simon system.
Hello everyone, welcome to my embedded system and IoT capstone project presentation. The title of our project is Smart Interactive Memory Trainer using Microcontroller-Based Simon Says Game. This project is designed to test and improve users' memory through an interactive pattern recognition system. The concept is simple. The system blinks a sequence of LEDs and the user must press the corresponding buttons in the exact same order. Each time the user gets it right, the level increases, making the sequence longer and more challenging. If a mistake is made, the red LED lights up to indicate game over, and the system resets to level 1. Now let's look at the program that controls the entire operation. At the beginning of the code, arrays are created for both LED pins and the button pins. This makes it easy to control multiple LEDs and buttons using simple loop instead of repeated code. A variable named red LED pin defines the red indicator light. Two key variables are used which stores randomly generated LED pattern and which keeps track of the current game stage starting from level 1. Setup function explanation. In the setup section, each LED pin is configured as an output, while each button pin is set as an input with an internal pull-up resistor. This means buttons are active low, so they send a low signal when pressed. The serial communication is initialized to display the game's progress, such as level numbers and button presses. Finally, a random seed is generated from an analog pin, ensuring that each new game starts with a different LED pin. Main loop explanation. Inside the loop section, the code first prints at the current level and generates a random sequence LED. Each LED in the sequence blinks for half a second, creating the pattern the player must remember. After showing the sequence, the system waits for the user's input. The program continuously checks which button is pressed, records the input, and compares it with the generated sequence. If the user presses the wrong button, the program prints game over. In the serial monitor, turns on the red LED for 1 second and resets the game back to level 1. If the input is correct for all steps, the red LED blinks briefly to indicate success and level increases by 1, starting a new, longer sequence. The hardware setup consists of the following components. CC3200 microcontroller board serves as the core processor controlling the game logic, LED patterns and button inputs. 4 push buttons represents the user interface for repeating the LED sequence. 4 LEDs provide visual output for the sequence using a mix of violet, purple and 2 additional LED colors. 4 220 ohm resistors connected in series with LEDs to limit current and protect the components. 4 4.7 kilo ohm resistors act as pull down resistor for the push button, ensuring accurate digital readings. One red LED used as a visual error indicator in place of a buzzer. USB power supply powers the board and enables communication with the Energy IDE through the serial port. This simple but effective hardware arrangement allows smooth signal control and reliable feedback to the player. In the circuit, each LED is connected to a separate GPIO output pin of the CC3200 through a 220 ohm resistor. Each push button is connected to a GPIO input pin along with a 4.7 kilo ohm pull down resistor, keeping the input low when the button is not pressed. When a button is pressed, the microcontroller detects a high signal and compares it with the generated LED. All inputs match correctly. The system advances to the next level by adding one new light to the pattern. When, whenever a wrong input occurs, the red LED immediately turns on, indicating a failure. Simultaneously, the serial monitor shows the message wrong sequence, game over. After displaying this message, the system resets to level 1, ready to begin again. The software is written in C language and uploaded using the Energia IDE, which supports the CC3200 platform. The main algorithm operates in the following sequence. Initialize all GPIO pins for input and output. Generate a random LED sequence using the built-in random number generator. Blink the LEDs in the generated order for the player to memorize. Wait for user input through the push buttons. Compare each button press with the stored sequence. If the input matches, print correct sequence on the serial monitor and increase the game level. If an error is detected, activate the red LED, print wrong sequence, game over, and reset the level to 1. The program structure ensures fast response, accurate comparison, and clear visual feedback for every round of the game. Beyond the standalone version, the system offers IoT expansion possibilities. The CC3200 has inbuilt Wi-Fi capability, allowing performance data such as the number of levels cleared, reaction time, or error count to be transmitted to cloud platforms like ThinkSpeak. This integration would enable remote monitoring and analysis of a user's performance trends over time. With such data analytics, the system could evolve into a smart IoT based cognitive trainer combining embedded electronics with cloud computing for real world application in education and therapy. When the system is powered on, it automatically begins at level 1. An LED blinks once and the player presses the matching button. If correct, the game proceeds to level 2, replaying the previous sequence and adding one more blink. As the level progresses, the pattern becomes increasingly difficult to remember. If wrong button is pressed, the red LED glows instantly, providing immediate feedback. At the same time, the serial monitor displays wrong sequence, game over. The system resets automatically to level 1, ensuring continuous gameplay without manual restarts. This cycle of progression and reset makes the system both engaging and educational. The system performs efficiently, generating accurate LED patterns and responding correctly to player inputs. The use of a red LED instead of a buzzer provides a clear, silent indication of an error, suitable for laboratory or classroom environments. Practical applications include memory training games for students, cognitive skill development for children, rehabilitation tools for patients recovering from neurological conditions, human machine interaction studies, This design is compact, reliable, and scalable for further development. In conclusion, the smart interactive memory trainer demonstrates how embedded systems and IoT technology can be integrated to create an interactive, educational, and engaging platform. Skills. Thank you for watching my presentation on the smart interactive memory trainer using microcontroller based Simon Says game.